Alright, hello everyone, welcome to my channel. Today we are doing class 6 mathematics, Ganitha Prakash, chapter 1, patterns in mathematics. So first, let's understand what mathematics is actually. So here it's telling mathematics is usually the search for patterns and understanding why such patterns exist. Now, patterns, they come all around us, like in nature, in our homes, schools. Like, take brick walls, for example. On one layer, we'll have one brick, then on the side, another one, then another one, then another one, and you keep going. Then you go to the next layer, put a brick, put another one, and keep going like that. Keep doing this layer by layer by layer. Or even look at this one at the top. First, we start with one ice cream stick. Then we add two more to the side. Then we add four more, two on each side, to this side. Then we add four more, and then four more, and we keep doing this again and again. Now, this is also a pattern. And it's not just here, we can also find it in motion of different celestial bodies like the sun, the moon, and even the stars. They come everywhere. Like anything we do and see, shopping, cooking, like throwing a ball, playing any kind of game, can be outdoor, indoor, doesn't matter. Understanding the weather patterns, technology, everything uses patterns. So the search for such patterns and explanations can actually be quite fun. Now you might think it'll be really boring because maths is boring. But I assure you, this will be fun. Now, it's because of these patterns that maths is kind of like an art and a science. So mathematicians believe mathematics is an art and a science. Now let's get a chance to see the creativity and artistry in discovering and understanding such patterns. Now, remember, mathematics aims not just to find out what the patterns exist, but also why they exist. And such explanations can be found in applications beyond the context of what we discovered, which can help propel humanity forward. So, these patterns can help us in life and all that. So, it's important to learn it. Take the example of understanding patterns of the motions of stars, the planets, and satellites. It's because of this that humanity was able to find the theory of gravitation, gravity, which helped us launch our own satellites, sending rockets to moons, Mars, like, Chandrayaan, Mangalyaan. Like a few years back, we launched Chandrayaan 3 on the moon. Some of you might remember. And same way, understanding patterns in different genomes, like our genes, in biology, like our genes, like they make us, like they come from our parents and all that. So these patterns in these genes can help diagnose and cure diseases, and alongside others stuff. Now let's have a look at this. Can you think of other examples where mathematics helps us in our everyday lives? Now you can think about it for yourself because there's a lot. And how has mathematics helped propel humanity forward? Think of examples like carrying out scientific experiments, running economy and democracy and all that. Now, let's start off with patterns in numbers. Now, the most basic patterns that can occur in mathematics are number patterns. Basically, patterns in whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, and so on. The branch of mathematics dealing with such patterns of whole numbers is known as number theory. So let's learn about this number theory for now. Now, number sequences are the most basic and most fascinating types of patterns that any mathematician can study. Now, let's see some important number sequences that we can see in mathematics. Like take this one. 1 1 1 1 1 1 1 1 1 1 1 1. Basically, it's just all ones. Next up, we have 1 2 3 4 5 6 7 8. You know how you count your numbers. Next up are the odd numbers, that is 1 3 5 7 9 11 13 and so on. Next up are the even numbers, that is 2 4 6 8 10 12 14 16 and so on. Then there is triangular numbers, that is 1 3 6 10 15 21 28 and so on. Then we have the square numbers, 1 4 9 60 25 36 49 and so on. Next we have the cubes, like 1 8 27 64 125 216 and so on. Then we have something called a Virahanka numbers. These are also known as prime numbers. There's 1 2 3 5 8 13 21. Now these are quite some special numbers. Now we also have powers of 2 1 2 4 8 16 32 64 and even powers of 3 1 3 9 27 81 and so on. Now let's visualize these number sequences. Now many of these number sequences can be understood through objects or our pictures. Also, by the way, these Virahanka numbers, these are known as Fibonacci numbers. They're in Fibonacci sequence. You learn about them, or I believe you have learned. Now many of these number sequences can be seen using pictures. So visualizing such objects through pictures or diagrams can be interesting to understand these patterns and concepts. Let's take these first 7 patterns that we have and represent them using pictures. First of all, we have all ones. We have 1 dot, then 1 dot, then 1 dot, 1 dot, 1 dot, 1 dot. You get the point. Next up, counting numbers. We have 1 dot, then we add another dot, so 2 dots. Add another 3 dots, add another 4, add another 5 and so on. Next up, odd numbers. We have 1 dot, now we add 2 dots, giving us 3 dots. Add 2 more dots to give 5 dots, 2 more for 7, 2 more for 9 and so on. And even numbers, starting off with 2 dots. We add 2 more to get 4, adding 2 more to get 6, adding 2 more to that to get 8. And adding 2 more to that gives us 10. Now for triangular numbers, this is fun. So we start with 1 dot, then we add 2 dots to give 3. After that we add 3 dots to give us 6. Next we add 4 dots to give 10, then 5 dots to give 15. Next up, squares numbers. First off 1 dot, then we make a square out of these dots. So we have one square with 2 dots on one side and 2 dots on the other, giving us 4 dots. Next we have another square with 3 dots here, 3 dots here, giving us 9 dots. Now here we have 4 dots on one side and 4 dots on the other, giving us 16 dots. Another square has 5 dots on one side and 5 dots on the other, so it has 25. Now for the cubes. Let's say you put one cube. Yeah, we can't use dots here, so we put a cube. Now let's put some cubes. So I get a cube with 2 cubes on this side, 2 cubes on this side, and 2 cubes on this side, giving us 8 cubes. Now we have 3, 3, 3, giving us 27. Now we have 4, 4, 4 cubes, which gives us 64. Now we have 5, 5, 5 cubes, giving us 125. Now let's move on. Okay, so just try doing these exercises. Now the reason that this 1, 3, 6, 10, 15 are called triangular numbers is because, as you saw here, they can form triangles. You can arrange the dots in such a way that they form a triangle, like this, with 1, 2, 3, 4, 5. It just keeps going on like that. And these numbers are called square numbers because, as you can see, they can form a square, like a square arrangement out of these dots. Alright. And these numbers are called cubes because these can form cubes out of cubes. You see, we have 1 cube, 8 cube, 27 cubes. These can form a big cube. So that's why these are called cube numbers. Now you will see that 36 is both a triangular number and a square number. So it is true, 36 can be arranged as a triangle, but also as a square. Now the thing is, 36 dots arrange perfectly as a triangle and as a square. Now you can try doing it yourself, you can check it out yourself, it will come. Now for this sequence, this is interesting. So I have 1 dot, now we surround it with a bunch of dots to give 7 dots. Now we surround it with a bunch of more dots to give us 19 dots. We surround it with some more dots, giving us 37 dots. So what do we call this sequence? We call it hexagonal numbers because, as you can see, they can form a hexagon, which is a polygon with 6 sides. Basically a shape with 6 sides. You can try doing this yourself. Now let's go on. Here is a pictorial way of representing powers of 2. So you have 1, 2, 4, drawn like this, 8, drawn like this, 16. It's kind of weird, but it can be a way to visualize all that. Now for relation amongst the number sequences. Now sometimes these number sequences can actually be related in some ways you would not expect. Like take all the odd numbers and just add them all up. Start with 1, 1. 1 plus 3 gives us 4. Now let's add 5 to it to give us 9. Adding 7 to 9 gives us 16. Adding 16 and 9 gives 25. Adding 25 11, you get 36. Now wait. What's going on? That's right. You can see that when you add consecutive odd numbers, you'll get square numbers. It's quite a nice pattern. Now this can go forever and ever and ever. It can never end. You can't just stop it like that. It'll just go on forever. Now let's see, like a picture can help explain this. Let's try visualizing this with a picture. Remember those square numbers made by counting the dots in square grid? How do we split that up into like 1, 3, 5, 7? Think about it for a second. Now here's how you can do it. You can just draw like this. Now we have 1 dot. Here we have 3. Here we have 5. Here we have 7. Here we have 9. Here we have 11. So we can see 1, 3, 5, 7, 9, 11 gives us 36 dots. If you can count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So all this is 36 dots. Because such a picture can be made from a size, any square size. This can show why adding up odd numbers gives us square numbers. Now here's another example. Take a look at this. We have 1, 1. 1, 2, 1 gives us 4. 1, 2, 3, 2, 1 gives us 9. And 1, 2, 3, 4, 3, 2, 1 gives us 16. And 1, 2, 3, 4, 5, 4, 3, 2, 1 gives us 25. And so on. Now this is another way to get these square numbers. By adding the counting numbers up and down. As you can see, we start from 1, 2, 3, 4, 5, 6. Stop there. Go down 5, 4, 3, 2, 1. And we get 36. Now here's an activity for you. Try finding out how we can do like that. Now here's how you can do it. You can just draw a line here, then draw a line, then draw a diagonal, keep drawing diagonals like that. And you'll soon be able to find that you can just partition it like that. Anyways, now for some patterns in shapes. Now some other important and basic patterns that we can find in mathematics are patterns in shapes. These shapes can be of any dimensions. They can be one-dimensional, two-dimensional, three-dimensional, or even more, like 4D, 5D, things like that. Of course, we are not really gonna learn that, but it is possible. For now, we'll focus on 1D, 2D, and 3D. Now, the branch of mathematics dealing in patterns and shapes is known as geometry. So, you might have heard of geometry somewhere, like shapes and stuff. So, this is what geometry is, finding patterns in shapes. Now, shape sequences are very important, they are quite important for studying mathematics. Here are some shape sequences. Here we have some regular polygons. First, we start with three sides, triangle. Now you might ask, why not one or two sides? Well, actually, you can find that out yourself. Go try it. So we have three sides, triangle. Then four sides give us a quadrilateral. Of course, you might say, but that's a square. But actually, a square is a kind of quadrilateral. You'll learn about it when you go to higher standards. Anyways, this is five sides, pentagon. Six sides means it's a hexagon. Seven makes it a heptagon. Eight sides makes it an octagon. Nine means a nonagon, and 10 makes it a decagon. Now we have some complete graphs. Let's say you take two dots, you can join one line. Take three dots, you can join three. And take four dots, you can see 1, 2, 3, 4, 5, 6. Now for 5 dots, you can get 10. And 6 dots, well, it just keeps going up from here. Now you even have some stacked squares. Put a square, stack it with some squares, stack it with some more squares, more squares, more squares, more squares. So you can see, you can just stack it up like that. It just becomes a bigger and bigger and bigger square and all that. Now for stacked triangles. Put a triangle. Stack it with some more triangles. More triangles. Now some more. Have some more triangles. So you can see, just like the square, adding more triangles makes the triangle bigger, 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 bigger. Now this is something called a Koch snowflake. It's kind of like a snowflake, you know. Some of you might have seen snowflakes falling in the sky. This is a Koch snowflake. So you take a triangle and divide it into this shape. Further divide it into this shape. Keep dividing, and you'll get something like this. Of course, you need not learn this much detail. You'll learn that in higher standards. Anyways, now let's have a look at relation to number sequences. Now, shape sequences are actually related to number sequences in ways you would not expect. Now, these relationships can help in studying and understanding both shape sequences and number sequences. Like, let's go back to the regular polygons. So you saw 3, 4, 5, 6, 7, 8, 9, 10. Again, you might know that's just counting up and down, you know, increasing order numbers. So you get a regular triangle, a quadrilateral, that's a square, a regular quadrilateral, then regular pentagon, regular hexagon, regular heptagon, regular octagon, nonagon, decagon, etc. Now, what do I mean by regular? Now, what I mean by regular is the fact that all the sides of the shape is the same. They're of same length. Like take this triangle. This side, this side, this side, all of those sides are of equal length. But also equal angles. That's the sides look the same and the corners also look the same. So like the space between this one, this one, this one, these angles, these are also the same. Now, we'll learn more about angles in the next chapter, so wait for that in our next video. You'll learn more about it. Now, the other shape sequences also have some relationships. If you want, you can check that out for yourself. Anyways, that's the end of the chapter. Let's end with a summary. So mathematics can be seen as search for patterns and explanations for why those patterns exist. And among the most basic of these patterns are number patterns or number sequences. Some of these include counting numbers, odd numbers, even numbers, square numbers, triangle numbers, cube numbers, Virahanka numbers, powers of 2 and all that. And sometimes these number sequences can be related to each other in beautiful and remarkable ways that you would not expect and that are actually shocking. Like adding up the sequence of odd numbers starting with 1 gives you square numbers. Of course, tell me, did you expect that? Definitely not. Anyways, visualizing such number sequences using pictures can help understand these sequences and relationships. And shape sequences, these are another type of patterns in mathematics. Now, some important shape sequences are like regular polygons, complete graphs, stacked triangles, and stacked squares, and even snowflake iterations. Now, these shape sequences also show many interesting relationships with number sequences. And that's the end of the chapter. Thank you for watching. See you in the next video. And please like and subscribe if you really enjoyed. Thank you.